thing. Okay. All right, guys, so before we get involved into the whole demonstration, I just wanted to do a quick recap on the topology. So when I do the demonstration today, I just wanted to give you guys a reference on how it's actually going to look when I do it in the actual lab. So here's the network topology. So on site A, we got Sydney, which is a primary active site. Site B is Melbourne as a secondary active site. And my apologies for being biased on the names, I had to do it. So what we got is basically, if you look at it from a top-down perspective, you'll see these two lines, blue one and an orange one, going back and forth. That's our universal logical switches, is what Dimitri described. That allows the applications to give you that L2 adjacency between two sites. So if you go up the stack, we've got that universal distributed logical router, and that's the default gateway locality that gets rid of the tromboning and all those bits and pieces. Then we go up to the next hop where we talk about the edge. And the edge is an autonomous edge which sits on both sites. And that's responsible for the whole north-south border advertising protocols in and bringing them in to attract the traffic for the respective data center. Then we got the WAN. So basically in this WAN environment, you can consider it every day in your own type of environment where you have your access networks aggregating into the WAN that you can talk to DC1 and DC2. So pretty straightforward. So if we go through the actual traffic pattern for this. Wait one second. It's gonna go. Okay, go. No, quick question. Oh, it's going. Oh no. All right. So that VM came to life, which is why I had to stop. So basically, we're talking about a north-south data pattern. But what's very interesting is that we need to consider the whole east-west thing. So if we look at that application moving from site A to site B, we're going to do the whole cross VC vMotion, and that cross VC vMotion will be doing it via v26. Off he runs, and he saw a beer, and he's drinking away. He's downing that pretty fast, by the way. And then as we go in, VXLAN comes in, whacks it, and catches it. So basically, that was a good catch, by the way. So we want to stop this whole east-west movement for VXLAN. So we want to get through that. So I'll take your question really quickly now. Yeah.
Are the web tier and app tier actually supposed to have the same subnet?
Okay, so the web tier and app tier are two different subnets, two different switches.
I mean, you've written them as the same.
Oh, that's a mistake. Mistake. Yep.
I'm just making sure.
You're right. Yeah. All right, so to go to the next step, basically we've been working with a customer for the last couple of months, and just as this came about was they had one site that's active, but one that's actually in standby or DR. And what they wanted to do is start moving that DR site to be more active. So basically, we wanted to start small, and define the requirements. So with the stretching and the egress was fantastic. And then the second part was with their applications being in the DNS server, they wanted to do round robin. So no matter where the application sits, whether it's on the left or whether it's on the right, we want to attract the traffic on the respective data center. And that's kind of where it all came together. So if I will give you the big picture of the lab that I'm going to be doing for you guys this afternoon, that'll be the next slide. And what we got is basically we're going to go through the same pattern again. We're going to go through showing you the active and its standby when it commences. Takes a bit of time. Eventually. Says it's playing. All right, cool. So packet comes to back and forth between the egress and to the cloud. We know the primary data center is the way it is. So in the event of a vMotion taking place, we're going to move an application from site A to site B, and that site A to site B is going to be represented through the vCenter migrations. Off it goes, and this is very key. So we want the application to say, pick me into that router. That router will then wait for the address from the guest operating system. We're going to pass up a /32 into that route. So the most specific thing that we need to figure out here now is that edge will route towards the DLR, but the edge more specifically is now going to update that WAN border router above it. And then we're going to pass that route via OSPF into the WAN, and then therefore the /32 route gets injected. Right, we're good. So when we talk about advertising routes, the most /24 prefixes, which is the subnet route, summarization, will always go via site A. So applications in the web tier will always go via localized routes there. But for the event that a migration takes place, we're going to inject that /32 route, and we're going to be able to do the rewrite and bring the traffic into that local site. So fundamentally, what we're describing here is kind of like a policy-based routing anywhere in the data center, because when you start coupling applications that you can write, then you can start thinking about how I can peer from the edge and talk into the network and start to attract traffic in an automated fashion. Now, the top part at the top there is basically describing the script that I put together. Now, that script was based on PyVomi. Has anyone ever heard of PyVomi? So basically, that's an open source SDK for vSphere. So to get that stickiness to talk to NSX, talk to vCenter, we've got to start looking at the data objects and what we can talk about. So with PyVomi, I'm able to get these two autonomous VCs together, use the object model, collect the data, and then I can start building functionality and software with a separation of concerns, saying that site 1 will have cluster, will have host, and I'm going to give it a site city name, and then instantiate that for site B. So that's how I'm building this data collection and VM locality in my code. So once you've got that, then you've got the architectural style of REST that you see in NSX. So REST being the push, post, and the delete. So based on the event of a migration in my application, I'll say, great, I'm going to inject a route there. When I want to move it back, I'll take it and put it back to representing the /24. So that's really the overall macro view, the big picture of how we're doing the ingress optimization based on the mobility of an application. So having said that, we'll go into...
Quick question.
Yep.
If I'm not an expert in networking and don't understand everything you said, then do I have to understand all of this, or can I just use your tool and the magic happens?
Absolutely. So with this, the app for the northbound, that's all automated. So in the event that you're moving an application in vCenter, I'm going to go in, right-click, migrate, move. You don't have to think about the networking aspects. We do everything from the edge. So if you think about the traditional manner in ingress optimization, you've got to think about techniques that you've got to sniff the package, you've got to do some sort of neighbor solicitation, you've got to do some advertisements, and it gets quite complicated to do some steering. Here we kind of take it from the inside out, so we've got that view on get the intelligence from the data objects, grab the rich and meaningful data inside every virtual machine through PyVomi, then I can start injecting through NSX, all completely automated.
And I don't need to understand your script.
Exactly.
I just use it.
Exactly.
That's what I like.
Yeah. PyVMOMI.
Or you do like me, you don't have to learn to write it down, you just use the script.
All right, so.
Oh, did you switch? Yeah.
Yep.
You need the password.
That's okay. We'll look at Dimitri's password.
That's okay, it's done with the French keyboard. So you'll never oh, and of course we lost you can
tell this is a real live demo that we're going to do.
I haven't thought about that.
Okay.
I lost VPN, so I'm connected, it will come back.
Okay.
That's when you do your dance. You know,
Okay.
we planned that.
Yeah. All meant to happen.
So I have the VPN, so it will just reconnect. I will have to remember next time we do the... Here
All
we
right,
go.
fantastic, great. Okay, guys.
That was your time to drink a beer.
So,
okay, now it's over. You follow.
Okay, what we've got is basically enhanced linked mode. So we've got VCA and VCB. So DC1, DC2, which represents site A, site B. So if I scroll down the console here, you'll see that I've got my clustering configuration correct. I've got my web app and DB tier sitting at the cluster level. I've got my edges for my management and edge clusters. And if I scroll this out more, just for everyone's awareness, you'll see here that, like you mentioned in the diagram, we've got one edge for site A and then one edge for site B. So that's basically what we've got set up. So if I go into NSX, we go into logical switches. Take some time. And then you'll see here that we've got the web tier connected to the global web, which is basically spanning L2 across multiple sites, right? And for the L2 adjacency. So for the edge, we got the gateway where we got that north-south border so we can attract the traffic to the respective data center. So edge 1, it sits here, and if I click the drop-down box and go next, then we can see it here as well for the secondary. So that's how it's kind of all done.
That's pretty cool. That's the NSX 6.2 enhancement where a single NSX can manage multiple vCenters on different sites. And those can be up to 150 milliseconds latency, so more than San Francisco, Paris. So it's pretty much like you can do very, very distant sites.
So I'm just going to click that application, that 10.0.1.11, and you'll see here that I'm actually hitting that web browser. So I'm actually hitting that web tier that we're going to focus on, the .11, very specifically. So if I look at a WAN router today, we will see here that if I do a show IP OSPF on the actual WAN router, we will see that we're advertising the /24 prefix up here. These three up here, 10.0.1.0/24. So basically, what we're saying here is all traffic for that subnet, go to site A. We don't care about site B. It's summarized there. That's all great. Now, just to show you guys the path that it will take, if I do a trace route to that particular web VM, we will see here that it's going via 21.21.99.1, site A, and then more specifically, the UDLR that Dimitri mentioned is for the egress. So you can see the mapping in IP is actually different, and you'll see that over time. That's actually going to a site A, and we'll go more into that. So that's the introduction to that. Now,
so what happens if you move now?
All right, so let's show them that.
Oh, before, yeah, you start your script before.
So what I'm going to show you guys is a Python module that I put together with the vSpheres SDK and so forth. So here you'll see an ingress optimized information here on the CLI that you can actually start building like that whole separation of concern, so you know what clusters and what hosts in and what site. So I've actually developed that in the module. Here I've tagged it with the representative of the city. So that city owns all those clusters. It owns all those hosts. And you'll also see for the city of Melbourne that it's got its own one as well. So,
and did you hard-coded that in the script, or do you learn that?
That's user input.
Yeah.
That's going to be for you guys to say, well, I'm going to go from between East DC and West DC. You can label it yourself based on the infrastructure. So,
but then that's your tool that detects all the clusters. You did not enter all of this.
Right. So here we've got the secondary question at the bottom here, and it says, please select your secondary data center. Which one am I going to be interested for the ingress optimization? So my one over here will say, great, I'm going to pick the Melbourne data center and click next. Now, the next question it'll ask is, please tell me what VXLANs are we interested in for that ingress optimization. And for me, it's the web tier, where the web tier was 50,000. But to be very specific, it doesn't need to be just one. It's about being able to decouple policy from physical networks. So if I've got many web tiers on many subnets and many networks, we can put it into this UI tool here. It'll actually collate them together, and you can decouple from the network policy in one big container. So that's kind of what I've written for that flexibility. So for example, VXLAN 5,000 to 10,000. Give me all of them in between. Things like that. You can actually pick it yourself. So if I hit next to that, right now it will tell me that there were no VMs found at the Melbourne site. That's because I haven't put anything there. I haven't vMotion to it. But if I was to do provisioning, for example, I'm going to get a web VM, and I'm going to go through my management framework. I'm going to provision it to an ingress site. It would automatically find it and do an ingress optimized for that particular VM. So that just to think of those other things that can count into that equation. So having said that, we're going to go through the migration. So we'll go back to host and clusters view. We're going to pick VM web 01 as the example. I'm going to hit migrate. And we're going to follow the following prompt. So now we're going to do a vMotion between the two VCs for those who haven't seen it before. So I'm going to click my compute resource, click next. Then I'm going to click the clusters view. So here you can see data center 1, data center 2. You can actually see them between the two. So I'll click the radio box for data center 2. Then I'll click next. So I'll click next. It doesn't matter where we go there. We'll leave the networking the way it is. We're going to say OK to that. Then basically finish, and off it goes. So I'll just open up the recent tasks. You can see here that the vMotion is taking place.
That's a vMotion across data centers and across vCenters. First time I've seen that, I had a wahoo effect, and I didn't hear it from you. So, and you're hard to please.
Right. So it's going through now. We're going to 72%, and we'll keep a close eye on it. We'll get there in a second. 77. It's getting scary now.
Sydney is not that close.
There we go. All right. We've got the first message that came on my application on the right-hand side. You can see here, vMotion event detected. vMotion for Web01 has checked in, like Facebook, into Melbourne. Now, for the network event, it's done a static route. So these are two events that we see straight away. vMotion, network event. So if we go back into NSX, I'll go back into it, and I'm actually going to select the home, go back into NSX, hit the edge, go to the secondary site, double-click on the edge, go to routing, and you'll see straight away that's been automated as a /32 route straight into the secondary site. Now, you can see here that the web VM is 10.0.1.11/32, specific prefix, pointing towards the DLR, which is the local for that site 2, going back in that ingress fashion. But the bit that I actually find that was quite cool and kind of really motivated me to spend more time coding at nighttime was actually this last bit. I know it's very simple, but when you go into a router and do a show IP route, you can never see what that route's all about. And what I wanted to do was actually marry applications to the network. So then a description field will say, it's been ingress optimized for Web01. That Web01 has been tied to that address. So that's how you can get that visibility to know what's actually going on and what module's actually taking control of the networking between sites. So that's to get it to this stage. Now, if we now want to have a look at what it looks like from this perspective, we can go down to the bottom here. We want to go to that WAN router again. And inside that WAN router, we're going to hit the show run OSPF one more time. Now, what you're going to see differently is that you will see that 10.0.1.11/32 is now injected and connected into that routing table, and it's going to take that path via 22 network. That's going to be via site B. But like I mentioned in that nice animation, you'll see that everything will maintain being in site A on .21. So that's how we keep those paths the same. So just to make sure that we're all on the same page, and I'm not lying, I just want to click the application, make sure we can connect to it, which we can. We can still see it working. So it's going via that site B. Right. So when we do these things, it was almost like thinking that how that portability would work from a network perspective. Now, I guess the next thing is bringing the application back.
Can you also do that?
Can we also do that? So I've created the events in the code that once we think that we've done our maintenance patching on the primary site, we want to bring back that application from secondary back to primary, then we can do that. So basically, what we'll do is let's bring that VM back to site A. So we'll hit that, hit the host and clusters, find Web01 on the secondary site, hit the migrate. Let's go next. Let's hit clusters. Hit cluster A, compute cluster A, which is vCenter DC1. Hit next. One more next. There's a few more nexts. A few more next. A few more nexts. And finish. So off we go again. Back on the return path for the application to go back home. So basically, we'll let that run. I'll bring up the scripts at the bottom. Great, so we'll see you're at 53%. This must be exciting for you guys to see if it's going to work or not. So again, at 73%, so we should see the same two messages reappear again. So we're getting there. $89. Oh. There we go. Now, to make sure I've told you guys the truth, I actually will go back to NSX Edge and actually show you it's gone. Just so we're all, I'm not lying to you guys, it's actually showed you it really did work. So we'll go back into the secondary edge, and you'll see it's gone. There we have it. So that's called basically PBR anywhere, based on the things that you can write. But don't think of it just for this use case. Think about how much more software functionality you can write if you have access to PyVomit. You can build your own abstractions. You can talk to network in completely different ways. That's why we come here, because we can actually do this stuff. Networking is to be an API provider at the edge. So I highly encourage you guys to download from GitHub, which will be up there in a month's time. We'll have a associated...
So how people will be able to get that in their lab, or in their production even?
Yeah, so Dimitri and I were having a discussion about building an OVA for you guys. So we'll give you an OVA template with the script running inside. So when you actually deploy it, you'll have pretty much just the script pops up in your face and you put the inputs in. So you don't have to think about creating the libraries, creating all these things. I can make it a lot easier for you guys. So that's what our plan will be, and you'll find it on VMware.com.
Okay. Okay. So we're running late as always. Just before you go, so just the key takeaways, what have we talked about? So we just talked about the fact that, yeah, lots of enterprises, they have multiple sites. Now, what does that mean? That means different things for different people. Some people, like all of you actually, but that's what we see also talking to other customers, they use mainly multi-sites for active standby. But some of them, they would like to use it in an active-active fashion, but it has been complex for so many years, and they just don't want to go through the pain, and they're okay to buy resources inside too and have it only for disaster recovery. Now, if you want to keep it that way, fine. If you want now to go to the next level, then now you have the tools. So feel free to go to the next level, which is really to use your data centers in an active-active fashion and don't have those servers sitting there for nothing just in case something happens bad in the first one. And you can do that in multiple fashions. Remember, we talked about just local central L3, which is fine. But you can even now go to what I call the dream, and it's not that complex. If you want to do the script and learn the script, fine. If you're a geek and you have tattoos, go with it. But you don't have to, okay? You can just do like me. I take his script. I don't understand it. I just run, and oh, it works. Okay?